Hey everybody, hope everybody's having a good day today. What I want to do today is show a little bit about our acoustical louvers, go over some of our different products, show some installation um, of our louvers, uh, the the different kinds of our louvers, how they can be installed, where they can be installed, and things like that as well. So let's just dive right into this here. So IAC Acoustics. Again, to go this here is a Catalyst Acoustics Group company called CAG. CAG is a parent company of an elite group of acoustic, seismic, vibration, and noise control companies that together offer the broadest portfolio of noise control solutions in the market today. So getting down to the left-hand side, good old Martin Hirschhorn back in 1949 there in the Bronx started IAC Acoustics. So we've been around for 74 plus years and going strong still. My name is Darren Riley. I'm the IAC Acoustics HVAC product manager and engineer. I've been doing this for about 17 years now. And we also have Ryan Wheeler, who is with IAC Acoustics. He is the HVAC project manager and also engineer as well, with about 10 years plus years of industry experience. When you look at our louver products, again, you can go right onto our website there at IAC Acoustics and you can download our louver catalog in PDF format. It has a lot of really good information in there. It has a lot of the different specifications and performance cut sheets that is needed. So at your time, at your leisure, go to our website there at iacacoustics.com and you can actually download the complete PDF format of our louver brochure and or catalog. Also, the louvers are on our HVAC virtual tool. So the silencers and louvers together are combined on here. The virtual tool provides valuable information for acoustic consultants and engineers. It has a quick select menu for prompt processing for the louvers, flexibility to compare our products with the other known alternatives that are out there, our competition. Things are customizable, option and expedited results. You can save and revisit these multiple projects at any given time. And what I really love is that our virtual tool is compatible with the smartphone and tablet devices. So if you're an engineer, we have an engineering version for this as well. So please feel free to go to our iacacoustics.com websites, look up for the tools, and you can sign up for this here as well. That way you can help generate the smittles. And what's really being nice, we are updating this tool on a quarterly basis here, little bit by little bit, as we hear from our friends and engineers and louvers and consultants and reps and customers, is that we want to be able to now provide this as for scheduling. So that is on the matrix. That's coming up pretty soon. So that way you can actually, whatever you do put in here for louvers and also silencers, it will also generate and create a full-blown schedule for your project. Looking at the difference here, we have our noise shield and our slim shield louvers. And on the left is our noise shield louver. That's our model R, 2R, LP, and our 2LP, which you'll see here in a minute. And that is the airfoil type blades. So, and then when you look at the slim shield type louvers, those range from 4-inch to 6-inch to 12-inch and 24 as well. We are going to be increasing our louver capability. We are in the mix right now of designing and implementing the SL8 and SL10. That way we have an 8-inch and a 10-inch depth louver there as well. And I'm also then currently working on a SL2 for a 2-inch depth louver. I've been hearing about this a lot for louver screens, so which is kind of nice. But when you take a look at this here and you look at all the different features of our louvers, it's a rugged steel galvanized construction. It's C-channel all the way around, the top, the sides, the bottom, all of it, you name it. Inside the actual louver blades themselves, just like splitter blades with silencers, the louver splitter blades are solid on the front face and they are perforated on the back side. And inside the louver blades are vermin-proof, weather-related, non-combustible acoustic fill type fiberglass material. Now again, for the noise shield, That is a airfoil shaped splitter blade. Again, this helps for maximum noise reduction with minimum pressure drop. These are great. For the Slim Shield, these are a more straight blade, a linear blade appearance for superior high frequency performance. Number 4 here is the perforated splitter underside for maximum sound absorption. We can do a solid back if these are just going to be needed for aesthetic look only, not for acoustical. We can do a solid back and leave out the infill there as well. Again, thus having just a aesthetic type louver as well. Number 5, weather stop, inhibits rain or snowy entry. So on the bottom of each of the blades is a weather stop. This helps to make sure that our louvers are wind driven rain. And also, again, it inhibits the rain from being able to penetrate up and through and through the actual louver, causing some wind-driven rain capabilities. For the number 6A, for noise shield, again, these are 12-inch for single blade or 24-inch deep for a double banked system, and those are typically done with a chevron look, which you'll see here in a little bit. For the Slim Shield, 4, 6, and 12. These can also be done as 24 inches in depth also. Number 7, the availability for a durable, attractive finish. We can do these in a powder coat finish. We typically use Sherwin-Williams or Tiger Drylac. We can do Kynar applications. We can also have a mill finish for aluminum. We can do anodized for aluminum. We can even do anodized for galvanized and also for stainless steel. So we can do those. Just let us know what the project description needs. If there needs to be a custom type color, we can do those as well. Typically, what we would like to ask for is a paint chip or a color chip that is needed. We can send it out to the shop, and then the shop can actually work up what the color matrix needs to be, and we can match those colors. I have yet to have someone come back at any of our shops and say we cannot match a specific color, so that's great. Number 8, a modular size enable assembly of rectilinear louver screens of almost any size, meaning we can stack these, we can put them nested side by side. Again, just like silencers, there is a limitation on what we can build for structural and for durability, but the louvers can come a lot of times up to about 144 inches in height. For the Slim Shield, for the Noise Shield, and for the Slim Shield, roughly around about 120 inches in height. We can start out at around about 12 inches in width, down to 10 inches in width. I've seen these down even into 8 inches in width. So, but we can make these of modular sizes to, again, have a complete ensemble when these are put together. The louver blade orientation blocks the horizontal line of sight, basically enhancing both aesthetic and acoustic performances. So again, these are great for screen applications, which you'll see here shortly in some of our applications, seeing how they were actually molded and put together. And then again, bird screens are available in galvanized and stainless steel, along with the same thing with our insect screens. And we've also been able to make the screens, whether bird screens and or insect screens, we can make these to where they are removable. A lot of times these can come out, whether they might be aluminum and or stainless steel separate from the actual louver that's been powder coated. We can also powder coat either of these screens as well. They can again be either removable or they can be fully welded on, screwed on, tack welded on, things like that, or riveted. So that way they actually are part of the ensemble of the louver. We can also have these screens put on the back side. They can be put on the front side. And for the 24-inch depth louvers, when there's 2 of them banged together, creating a chevron look, they can actually go in the middle. So again, those are kind of some important things that we need to know. When screens are required, we need to know where they need to be placed upon the louver itself. Moving on, all of IAC louvers have been developed in response to specific requirements from acoustic consultants, consulting engineers, building owners, and contractors. Again, everything has been tested. The complete range of acoustic louvers for controlling the airflow noise in and around the air handling systems. Acoustic louvers for use around mechanical plant installations where acoustic barriers may need to be required. and that airflow is still needed to happen. And then again, aesthetic louvers that can come in many different shapes and sizes and can still carry performance requirements. All of our louvers have been tested performance utilizing the AMCA standard 500L testing criteria. Again, our entire line of HVAC louver products provide one of the most economical choices for solving the wide variety of airflow and noise control problems encountered in HVAC engineering. As you can see on the left, again, we can do all different types of shapes and sizes. We've done these, multiple arrays. We've done circles, we've done stars, we've even done triangles. So you can work up a sketch in CAD or just by pen and paper, send it to us, and we can be able to work that up ourselves with our engineering team. And then we can also put together a nice comprehensive package for you, letting you know how the performance is going to be and where the performance will be within that size or shape of louver. Duct science and louver operating principles. When you look at a louver, you have reverse flow and forward flow on the left-hand side, on the outside, and on the inside, you have your sound source. Now, I get asked this question quite a bit. Should we design to percent of free open area first, or should we design to performance? I'm old-fashioned. I'm going to tell you design to performance first. Percent of free open area will literally be what it is, tell you the truth. It will. There is a free area of the Model R and the Model LP, for example, here. It varies across the width because the blades are airflow shaped. So at the intake and discharge of the louver of the original opening here, you basically have 100% of free area, right? But at the closest point down to when it gets around about 18 to 20% of free area, because the diffuser effect on the discharge side, the outside, however, you actually get what is called a pressure regain, and the louver performs much better than, say, 20%, maybe 30% free open area. Based upon our testing and analysis, the Model R louver, the pressure drop performance is equivalent then to a straight bladed parallel louver with roughly 46% free open area, and the Model LP is roughly, again, straight bladed louver with a 50% free open area. So the pressure drop listed in our catalog is based on face velocity and across the entire face of the louver, not just the free area face velocity. There's a difference there. So for example, if you had a 10-foot wide by 10-foot high roof opening at 50,000 CFM, your face velocity would be at 500 feet per minute. Again, this face velocity would yield in a pressure drop of 0.27-inch water gauge for the Model R. It's actually not bad, to tell you the truth. That's actually great with that type of airflow. Now, some of our other manufacturers, though, they rate their pressure drop performance based upon air velocity through the free area. We, as IAC, again, we like to base our louvers on performance. So that is then based on air velocity across the rough opening, in which the case of the free area is not required for the calculation of pressure drop. We'll go over that here in just a second here. So when you're looking at a percent of open area here, if you take a louver, if you take that rough opening of 48 by 48, that is 100% free open area before there's a louver, right? When you say you put this louver in here, and this is our Model 6, our SL6, at a 48 by 48, that's 16 square feet. So on these, the louver blade thickness, across the face of the blade, okay, you're talking this thickness here, up and down, all the way across is 2.13 inches. And then in between each blade, you have 3.88 inches. That is the actual open blade spacing, again, in the light blue. So to figure this out, percent of open area, you're going to take the total of the blades, 8 blades at 2.13 inches, not across, and doing that, you're only taking the height, right? Because you're trying to figure out what is this percent of free open area here. You're going to times that by 8 because there's 8 blades at 17.04. So blades, the top sill and bottom sill. Then you have a 48 minus 17.04 to get 30.96. So this is now the total open area. This is right here. You're taking these blades is open blade spacing. So now you have 8 open blade spaces for the areas. 3.88 times 48 is now 186.24 square inches. Convert that to square feet is roughly, in times 8, each of them, you roughly have 10.344 square feet. Now you take that to percent of open area, you take that 10.344 divided by 16 blades and open spacing, and this is where you get your percent of free open area. So for example, this one here, if you look at this, 48 by 48 total hole is 100%. When you put this louver in through here, it is now roughly at 65% free open area. Again, we like to design to performance. I always tell everybody, design to performance first. Make sure that the pressure drop is in relation to the actual pieces of equipment and it's allowing the proper airflow. Once you have both of those working tandemly and correctly, percent of free open area will end up what it is. It will not harm the system because you've already designed it to performance, airflow, and pressure drop, making sure that you're not putting any impedance back on the pieces of equipment that it is actually enclosing. Acoustic louvers can be screens and ventilation openings. They can also be integrated as doors, which we'll see here in just a few minutes. When you look at our acoustic louver brochure catalog, we also have some typical details that are shown for supply of all supporting steelwork if necessary. We show that there's different ways of installing the louver with a flush exterior, a flanged exterior, masonry anchors, concrete inserts or anchors, flush with the exterior, and then also a bolted connection to HHS type tube steel. If you need any type of design work as well, IAC, our engineering team, can actually help out with that, and myself, we can actually help out with the design phase. We can actually help call out the appropriate tube steel, and we will also look at wind calculations as well to make sure that the overall height of the louver screen or louver wall or enclosure will be supported enough with the tube steel in conjunction to the wind rated that might be out there. When you're looking to how to specify acoustic louvers, we also have this in our catalog here as well for our noise shield louvers and our slim shield louvers. It gives a great typical specific details for how the casings are made, out of what gauge of material. It also gives the airfoil configuration for the noise shield or the straight splitter blades for the slim shield type. And then it also gives some good installations of how these can be used as well. When you look at our catalog here, you have the Model R and the 2R. Again, the Model R is our regular type. That's kind of what it stands for. These are 12-inch blade spacing. Custom blade spacing is available. Get with me on a specific case-by-case basis. We can do that. And the minimum starting height at these are at 18 inches in height. That encapsulates the top sill, the bottom sill, and at least one blade. The same thing with our LP. This is airfoil type and 2LP, whether 12 inches and or 24 inches in depth. These typically have a little bit lower pressure drop, which you'll be able to see that in the actual catalog. These are at 14-inch blade spacings. Again, custom blade spacing is available, but the minimum starting height for the model LP or 2LP is at 24 inches in height. And here's some really good calculations, being able to see the difference between the Model R, the 2R, and the 2LP, right? So when you look at this, we have 160 inches wide by 309 inches tall at 24 inches in depth. This is a humongous louver screen, right? At 116,000 plus CFM. When you do the nice little math, when you look at this equation up here at the top that we have done, that is down there in the aerodynamic performance column area down there in the mid-range. On the right-hand side is that equation. I apologize, it's a little blurry there. But again, that is right in our catalog. We like to be able to be transparent about how the calculations are derived. And so when you plug in this needed information, you get the entire area here at 343 square feet. Then look at the face velocity at 116,538 CFM. You divide that by 343 square feet to get your feet per minute. When you look at this, the delta at 0.25 pressure drop is actually at 0.25 pressure. They're almost pretty equal with what is down here underneath the static pressure drop underneath an aerodynamic performance at 0.25. Now, when you look at this and you see that that's 377, if you look at the Model 2 LP louver calculations, almost cut in half, really, if not more. It's at 0.212, because when you look at the same velocity, 339, you have to come over here then to the same face velocity catalog, and it is starting at 0.15 at 377. So when you do the math, that still calculates there. It is lower, 339 feet per minute than 377. You calculate that, you square feet it, and you get 0.12 inches water gauge for pressure drop. We also have the SL12 and SL24, just like the Model R and LP, but these are straight splitter blades. So we have the capability here, and these actually carry a little bit more transmission loss. And when you're talking about transmission loss, that is actually, again, you're trying, that is the loss that you're looking to recover on the outside. It's a little bit different than insertion loss. Insertion loss is when you actually take and you measure for insertion loss before and after the sound perpetuation when you're putting the silencer inside something, right? So you're measuring before and afterwards. Here, transmission loss is measured on the outside of the louver. Thus, this is what you're taking care of, is the noise and airflow on the outside of the louver from the pieces of equipment that are creating the sound. We also have our SL4 and our SL6 type louvers, the 4-inch depth and 6-inch depth. And again, we're looking to be able to now bring forth here about mid to late spring the SL8 and the SL10, which you will see out here in the next few months. And let's look at an SL6 louver calculation. Again, when you look at this, you're taking this one here. This is kind of a smaller CFM, but we converted BTUH 29,700 to CFM. And then when you look at this, again, I apologize. I'm sorry. I needed to scratch that out. I just noticed this looking at this. So I apologize. Actually, this is at 135,000 CFM for the SL6. Not bad, but this is a humongous area here. It was my bad on copying this over. So when you look at this, it's 180 inches wide by 1,200 inches high. 216,000 square inches, convert 1,500 square feet. Base velocity, 135,000 divided by 1,500 at 90 feet per minute. When you look over here at the table, you get 115 right here at 0.05. So you use that as your delta for your pressure. And you then get 0.03 inches water gauge pressure up. That is excellent for this size and depth of louver. Looking at a SL4 calculation, this one here I copied right. We're at 1,200 CFM here. So again, a little bit smaller louver. Again, these actually do great in smaller geographical areas as either kind of like a small little opening enclosure or even a small little wall type single enclosure as well. This one here calculates out at a 0.08 inches water gauge. Some application and installations to give you some overview of how our louvers can all be fit together. This is a waterfront substation in Washington, D.C., substation number 223. This is an excellent application showing the SL6 louvers, and you can see that these are multiple louver that created an entire ensemble of a wall, then with tubular steel creating the door frame. And then these are bolted to all the way through and into the tubular steel. And we actually helped create and design this entire turnkey application. So again, we can do that if need be. So just simply let us know. And you can see the size of this door here and things like that as well. So this allows equipment to go in and out of the actual substation here as well, and or for repairs or modifications or additions and things like that as well. So These are these are aluminum, so they are lightweight, and these have a clear anodized finish to them. On top, you can see again our SL4 louvers. These are the SL6, these are the SL4s, and these are complete louver screens. So these were a little bit customized. We had to make these a little bit customized, things like that as well, in order to create the entire width and height for this, but the shop was able to accommodate that and create this. And again, this is a nice Kelly green. Again, with Sherwin-Williams, what we would need is the RAL number. At the same thing with Tiger Drylock, we would need the actual RAL color number in order to accommodate what color scheme you are looking at. Here is the Intel Corp equipment room. These are a nice brown coated color. It's kind of a matte finish. These are in the equipment room for the exhausting area. So as you can see, these are inverted. So these are actually, the solid is on the inside to help airflow go out for the exhausting of the actual airflow that's inside this equipment room. This is what when we did the design, we actually worked this up, and you can see that there are multiple long, tall sections, right? So this one here is a louver, and you can see the C channel right here. Again, the C channel on the other side is for this louver. For the inside of it, this is the other side, and so forth. As you can see, these are going down. What they did is that they came back then for added support and steel structure framing, is they added flashing. In about every 4th to 5th louver, they created this. These are bolted together here, again, bolted together here, and then flashing right in through here. On the left-hand side, you see an L-shaped enclosure with the SL6 louver on a concrete framing network. And on the right side, you see a single line enclosure with the SL4 louver. Again, we can help design with the tube steel of how these can be actually installed. As you can see, these are notched. So the sides of the louvers can also be notched in accordance with the actual different type of tube steel that you have, to where this can account for bolting onto the side or the front face of the tube steel, and even to the back side or to the side of the tube steel. Let us know. And again, you can see right in through here as the louvers are mated together side by side that are nested, you can see that there's flashing that we can provide as well on the actual louver framing system in order to hide the actual C channel. Roof line equipment enclosure. This is really cool. This is here in New Jersey, and this is for a building complex there in Jersey City. And you can see that they help hide the line of sight of these pieces of equipment that are right behind here. On the right-hand side, you can see where this equipment is. On the left-hand side, you really cannot see these pieces of equipment behind here. So you can see, we took a picture of this on purpose to see through the louver blades, but in doing so, it also hides the line of sight of the pieces of equipment. And you can see these are actually our model LP, lower pressure drop. These are 14 spacing of our blades. You can see the airfoil blades. They're curved right here on the front side. And on the back side of it, it actually has, it's hard to see here, but you can see the bird screen. And then you can see right in here is the actual tube steel. It's kind of like a T-frame type steel framing system that we actually helped design. We did the wind load calculations to make sure the wind were going to be appropriate with this as well when these were installed. So we actually, again, those different type of calculations that we can help provide as needed. Our louver doors. This is something that a lot of people are starting to actually utilize now when they're looking at enclosures in order to help out with proper airflow of pieces of equipment, whether they are inside and or outside. At the top, you can see are the standard, those are stationary louvers up above, and then louver doors down below. To the left, you have a single louver door that actually has a right side hinge, so it swings left to right. You have double doors on the right here in the middle, on the left, and on the right, stationary louvers on the in the middle. And then on the far corner here, you have stationary louvers on the left and on the right with a double door there system as well. A lot of times what you're going to be utilizing doors for, the louver doors, is to make sure that you can get in, and if you need to remove and or work on pieces of equipment, That way equipment can either be swapped out for upgrades and or getting in there to actually work on the pieces of equipment as well. Mitered corners. This has become kind of a nice custom type requirement that we're seeing a lot on rooftop louvered enclosures. If you go back to the rooftop louvered enclosure here, you can see that this is actually the solid piece right here, this solid here. You can see that solid on the outside, this solid here, this solid mates up. You can kind of see that right behind here, right? So this utilizes the square format, right? When you look at how louvers can actually be designed now too, is that it can create a nice mitered corner to where the louver blades, this is a squared off section from the inside. This is this angled piece right here that's solid. But then what happens is that you get the louver blades coming together to create a nice aesthetic parallel looking. So that way it looks like it actually comes down the front face here and turns and goes down this other nice outside front face as well. So you have a really nice aesthetic look. Back behind here, the black shaded areas that you see here are the actual tube steel, the 10x6 tube steel. These are actually called out by others, but we can also showcase and how you're actually going to adhere and attach to that tube steel. Our engineering team has the capability of designing this and actually providing these type of details. Case here is 3" by 1.5" flat steel, and then you actually have your 1.5" by 2" bolts that are creating to that as well. Last but not least, a nice little job that we like to showcase here is the example of our acoustical louvers. This here was with the Progress Rail with the Caterpillar company. This was a couple years ago where we designed with the National Locomotive Rail Company. They needed to reduce sound reduction coming out of the locomotive engine. So IEC Acoustics was there to help. We worked with Jim Seaton, the locomotive engineering product line manager at Progress Rail, in an effort to run some calcs and simulations to help determine the size and type of louvers that would need to be best suited for their locomotive engines. Now, we do have the capability of running CFD simulations, aka which that is called computational fluid dynamics. We can do that, where these were used to help a design more of a natural ventilation system using our SL-4 slim shield louvers in conjunction with the analysis performed on the impact of locomotive engine exhaust to the environment. It was actually kind of fun running those CFD simulations. In here, we designed the IEC SL4 slim shield louvers to allow these engine locomotives to run at max performance without any impediment and to help keep the engines cooled with the allowable airflow in and out to avoid any kind or any type of heat buildup. What you see here installed are the Slim Shield SL4 louvers. These have been powder coated with a nice RAL number 5005, the nice beautiful signal blue color that you see, which is something that Caterpillar likes to use as well. So if you're ever on the roads and you see a nice train coming by, look for the Caterpillar company for the engines, and on the front of these engines, you're actually going to see or showcase our SL4 type louvers. Again, these help to make sure that the engine locomotive run at peak performance at the same time, making sure they never, hopefully never, I don't believe anything's ever 100%, but 99% of the time, they should not overheat. I want to thank you for your time today. If you have any questions about our louvers, about turnkey applications, about any of the performance, about any performance requirements that you might have on job situations, please reach out to me. You see my phone number, you have my website, email. Again, visit our website for the access to the extensive tools, the data sheets, and the product literature. Again, I'm here to help with any louver question or requirement that you might have, and we will be able to help, I believe, provide a nice, simple resolution for you. So thank you again for your time today. Make it a great day.